Welcome back for another science experiment. So before we get started, I'll just introduce myself. My name is Liz Hodgson, and I'm a volunteer with Pueblo Science. I'm also a student scientist studying neuroscience, which is the science of the brain. But chemistry is one of my favorite sciences because I find it so exciting, and we'll be doing a chemistry experiment today. The experiment that we're doing today is called fireworks in a jar. And Canada Day is coming up. Maybe you'll see fireworks in the sky. But today we're going to be making some liquid-based fireworks. All you need is some sort of cooking oil. I'm using canola oil. You need a clear jar or glass with some water. Warm water is best, and we'll talk a little bit about why warm water is best later. And then you need some water-based food coloring. You also might need a fork, just in case the experiment doesn't work as expected. All right, let's get started. So the first thing that I'm gonna do is put some oil into my jar of water. What do you think is gonna happen when I pour oil onto the water? So I didn't pour that much. I poured just a little bit. And already I can see that there's two layers. You can see white layer and then a thin kind of yellowy oil layer at the top. Now, it's really important to keep this oil layer really thin because I tried this experiment just a few minutes ago and it worked really well with a thin oil layer. So why didn't oil and water mix? Let's take a look at that. So water, this is the structure of a water molecule with oxygens and hydrogens. Water molecules are super good at forming associations with other water molecules. This is an oil molecule with these long zigzag chains that represent carbon. Oil molecules love to bind up with other oil molecules. But since they don't form the same kinds of associations as water molecules, water and oil do not mix. Let's try a multiple choice question to test your knowledge. Okay, why don't oil and water mix? Take a minute, pause the video to try and answer this question on your own. Awesome. If you said C, you're right. Water forms the strong associations with other water molecules, but it can't form that same type of associations with oil molecules. Let's get to the next part of the experiment together. So now I'm gonna add some food coloring on top of the oil. I'm using green, my favorite color. Let's go. I'm just doing a couple drops. You don't see anything happening right away, and that's A-okay. Take a look at what shapes or what do you see happening from a bird's eye view. I see that there's kind of islands of water-based food coloring within the oil. Remember, if this is water-based, it makes sense that the food coloring is not mixing well with the oil either. So I don't see anything really happening right away. Sometimes these, yay! Oh my gosh, okay. So that's great. In a previous time, if nothing happens, I use my fork to poke them down, but I just saw something happen automatically. That's a firework explosion. Amazing. I'm super impatient, so I'm gonna give it a poke with my fork, see if I can get a blue one. Wow. That's really beautiful. Oh my goodness. So the food coloring is sinking down from below the oil. The green one went automatically, but I find that they sometimes need a push, which is A-okay. You can use your fork to push them down. I'm gonna do another one. Wow. Wow. Oh, I think I got like multiple at once. Oof, that's beautiful. All right, let's take a minute to talk about why the food coloring might be sinking down. Things sink down because of their density. That describes how packed the molecules are. So up here is something that's super dense, super packed. And here's something that's less dense. Things that are packed like this are heavy, and things that are less packed are light. So think about a rock is more dense than water because it sinks in water. So that means food coloring is more dense than oil because it sinks down into the water layer. It also means that water is more dense than oil because it was below the oil to begin with. Let's try a question to test your knowledge. Why does the dye sink down below the oil? Take a minute, pause the video, whatever you need to give this question a go. You can comment your answer down below. All right. If you said A, you're totally right. Dye is actually made of water, and because those molecules are packed closer together, they're denser. So they're just simply heavier than oil. They'll sink down below. Nice job. Okay, so what else I'm seeing over time is that the colors here are really spread out. Wow. So when they were in those little dots at the top, or even when they're in the container, the molecules are super dark. They're really concentrated, which means that all the color is close together. But as soon as we put it in with water, it looks like the color is spreading out. The word for that is diffusion, spreading out, diffusion. Why do you think that the molecules are spreading out so well? And can we think of some reasons why temperature might help with diffusion? Let's take a moment just to review the concept of diffusion. Diffusion, like I said, is when it goes from a concentrated state out to a spread out state. But here's the thing. In hot water, molecules are moving around much faster than they are in cold water. That movement really helps with the spreading out. And it means that there's more spaces and places for the dye molecules to go. So in this picture, you can see that what we saw with our warm water was kind of in between this hot dye where they just spread out instantly and the cold dye where they just sink to the bottom and take a really long time to spread out. You have a really intermediate effect when you use warm water. That's really cool. So just to test our knowledge, let's do a last multiple choice question. So why did the dye molecules spread out? I know these concepts are new, but it's good to give questions a try to see if there's anything we can learn today, as well as see some beautiful art. Take a minute, comment your answer down below. Question 3. Okay. If you said B, you're totally right. Dye molecules spread out because they spread always from a high to a low concentration. And the movement of the water molecules, especially in warm or hot water, really helps with that. So now that we've seen a beautiful firework explosion, let's talk a little bit about different ways we can add on to this experiment. So here's some things that you can try. Use a different type of oil. Do you think it'll work with olive oil or peanut oil? Research the chemical structures of oil to see if they look similar or not. Try it with cold water or hot water. Do you think you can recreate the same effect and revisit the idea of whether diffusion happens faster in hot or cold water? Amazing. I really hope that you do try this out multiple times. It's really cool to see it with different colors. And thank you so much for joining in today. Keep on sciencing, guys. And you'll be doing another experiment with us next week. Amazing job,